In the dark matter lab, you're going to be investigating how this mysterious dark matter affects how stars orbit in the Milky Way galaxy. So in lecture, we talked about the Milky Way's rotation curve. So we're going to be looking at a curve like this. It's a graph that depicts orbital speed of a star in kilometers per second versus how far away from the center of the galaxy it is in light years in this case. And we expect, because when we look at the Milky Way, there looks like there's a lot of stuff in the center, and as you move away, there's less and less material, kind of like how our solar system is set up, where all of the mass is in the sun, and as you move away from the sun, there's less and less mass. But we don't find the stars in the Milky Way to obey Kepler's third law. So what happens is that after you get to a certain point, all the stars are moving at the same speed. This doesn't make any sense because based on what we can see, nothing can be pulling gravitationally on the stars to speed them up that fast. So where is this missing mass? We don't know. That's why we call it dark matter, because we can't see it. But we know that it's evenly distributed in both the halo of the galaxy and the disk of the galaxy. So when you go to click on the link to the simulation for the dark matter lab, it's going to bring up a window that looks like this. So on the left you have a picture of the galaxy, and the orange dots are sample stars orbiting around the center of the galaxy. On the right, you have a graph, which is a rotation curve because it measures velocity of these stars and compares it to how far away from the center of the galaxy each of those stars are in kiloparsecs, or 1,000 parsecs. So if you click Show Speeds, it will display the speed of each of those sample stars in kilometers per second, which is useful to answer questions about how the speeds are different closer to the center versus farther away. And you're going to want to click Show Sample Curves. So what these two curves are now on this graph, the bottom one is the Keplerian curve. This is what the rotation curve of the Milky Way would be like if it behaved like Kepler's third law, like our solar system, where all of the mass is in the center and very little mass is outside of that center. So it's just based on how far away from the center a star would be. The actual curve, what the Milky Way is actually doing, is this top line on top. So this is the Milky Way's actual rotation curve. And so what we're going to do is manipulate the simulation to try to figure out how much dark matter would make the simulation behave as the Milky Way actually does. So to do that, we're going to periodically click Snapshot. So when you click Snapshot, it will put on the graph the speed and the distance of the sample stars that are on the left part of the screen. So right now with zero dark matter, it behaves like Kepler's third law. All the mass looks like it's in the center, so the further away you are, the slower the stars are moving. But you can change the amount of dark matter that is evenly distributed in the galaxy, and when you click Snapshot then, you'll get a different curve because the additional mass is changing the speed of these stars because there's a different amount of gravity acting on them. So part of the activity is to figure out how much dark matter is in our galaxy and how does dark matter affect the orbit of stars around the galaxy's center. So like all the other labs, work through the worksheet and then there's a quiz on Blackboard.